Hello everybody, this is Dr. Sakti Zana analyzing the current paper, that is fault detection in beam structure using adaptive immunity-based approach. Particularly this was summarized like this one. So first we have developed one clonal section algorithms which has been applied to find out the faults, particularly that fault is nothing the crack location and depth in the structures. So later one such method which has been developed in the concept of adaptive immunity-based technology, that is ACSA, adaptive clonal section algorithms, which is the combination of artificial immunity, that is nothing the clonal section algorithms, and regression analysis. The use of regression analysis makes more adaptive and the residual errors in the collection of vibration data is reduced. The main objectives of the key endeavor of this study is to the development of the ACSA and its implementation to condition monitoring of structures, that is to identify the crack location and to measure the crack depth. To authenticate and check the accuracy of this method, that is the CSA and ACSA experiments are carried out in the laboratory. Mostly this picture has been architected in like this way: literature review, dynamic analysis, data acquisition, training of data using CSA, training of data using RSA, and training of data ACSA, that is nothing hybridization of CSA and ACSA. Then experimental methods, then result discussion and conclusions. Mostly in these pictures or this work we have considered a cantilever beam which is having length capital L. The crack is situated at a distance of L from the fixed end. Small d is nothing the depth of the crack and capital D is nothing the depth of the beam. So you see here how the experimental analysis has been carried out. Different numbers are there, 1, 2, 3, 4, 5, 6. So all the numbers here has been analyzed by the specification like vibration sensors, vibration analyzer, vibration indicator, impact hammer, or you can say power distribution. So what are the main objectives? The main objectives of this work is to develop the ACSA, that is the application of hybridized CSA and a regression analysis, that is nothing ACSA. Regression analysis is applied to find the correlation between the dependent and independent variables. Usually it has been observed that the patterns or methods used for prediction of the outcome data from the solution space or data pool. To establish the relation between the input and output variables and to reduce the effect of residual errors on the prediction of solution, the analysis are done. Due to the above mentioned reasons, the data generated from the data acquisition methods are trained in the regression analysis. After the training of the data in the regression analysis, the trained data are now trained again in the clonal section algorithms. You see, so here we have compared so many works, that is our dynamic analysis, that is in numerical methods with ACSA. Again, the proposed algorithm ACSA with the experimental analysis. There are different results are varying here for relative crack location, that is RCL and RCD. So you can find the percentage of errors between which one? ACSA and dynamic analysis, ACSA and experimental analysis. So here also we are showing the graph between the comparison of results between CS and ACSA for RCD and RCL. You can find here ACSA providing better results than CSA. You can see the first graph is for RCD, that is relative crack depth. Second graph is RCL providing relative crack location. You see what we are getting at the end of the study. This analysis includes the mechanism CSA, regression analysis, ACSA. The ACSA is the hybridization of CSA and RA. The results obtained from CSA and ACSA are compared with those of adaptive numerical model, which already we have shown in the table. The error percentage of RCD between the results of CSA and ACSA with numerical model data are about 4.6 and 3.51 respectively, while those of RCL are about 4.6 and 3.67 respectively. To check the correctness of the robustness of the proposed methods, experiments has also carried out in the laboratory. What is showing the percentage of errors between the ACSA and experiments for RCD and RCL are about 2.95% and 2.84% respectively. So from the our studies, what we are concluding? That ACSA yields good results and also convergent to the experiments results, which is a result about a error within 3% only. So the ACSA or the purpose methods can be very useful methodology or technology for fault identification in vibration structures. Thank you.